Good morning, everyone. Welcome to our presentation today for Revit and Advanced Steel Collaboration, Part 1. We just got to the top of the hour, so I'll probably kick off straight away. I'm going to try and keep this to about half an hour, so not take up too much of your time today, but thank you for attending. Hopefully you'll see in the interface, you should see a handout section. There is a PDF file in there, which is a copy of today's presentation. Please go ahead and download that. That should help you because there's a few hyperlinks in there, which should send you to some help pages. So I've sort of hopefully embedded those correctly and it should work today. So to introduce myself, my name is John Bennett. Obviously, I work for Graitec. I work as a customer success manager within Graitec, working predominantly UK, US, but I do travel around quite a bit. So a little bit about myself. I've been involved in structural engineering fabrication background for a very, very long time now. I'm not a youngster anymore. So I've been using Advanced Steel for some 16 plus years now. Started using that obviously in the real world, in the CAD environment, the steelwork world. We worked with it doing sort of structural fabrication, staircases and railings and stuff. Then came to work into what they call the channel. Worked for Autodesk for a while as well, and then came back to the channel recently, a couple of years ago. So a bit about our series of webinars that we're running currently. So Rob did one last week, which was sort of an intro to the series of 4 we decided to run. He talked about some of the joints, the custom connections, etc., and things like that. And then I decided to do a little bit more in the middle to do about collaboration and explain a little bit behind how this mechanism works to try and give people a bit of an understanding, especially when we're talking about 2 different industry sectors now, which is obviously engineers and structural detailers, and them crossing into each other's sort of areas. So that was sort of the middle 2. We're going to do part 1 of that today, and then obviously Rob's going to follow up with a Fabit 1 at the end, which is about sort of taking it into fabrication detailing. So part 1 we're going to cover today, and then obviously part 2 is next week, so you need to tune in for that next week. But this one today, we're going to talk about the extension itself, what the file is, how does it work, what are the different options amongst the transfer method, touch a little bit on materials as well. So there's quite a lot to cover. Next week, we'll go on to talk about approved families, steel connections, things like that. And then some of the new Revit steel tools in 2019 and how that's impacting upon Revit itself and the changes within the structure of that for the fabrication format, how that's also affecting the transfer elements as well. And hopefully along the way between the 2 sessions, I'll impart a few tips of working with Revit and Advanced Steel. So hopefully in front of you, you should see a little video playing. This was actually done by a colleague of mine who I've known when we were both at Graitec and both at Autodesk. And this was the video that came out sort of promoting the new custom connection and showing the steel toolbar that's now sort of appeared inside Revit, so on the ribbon. And this probably took quite a few people by surprise because this is probably the first time I've actually been able to see that you could add nuts, bolts, and washers, literally all the little bits and pieces that steelwork detailers would be familiar with as run of the mill. And obviously, when I saw this, I thought, oh yeah, I know most of those tools. They're Advanced Steel tools that have been transposed into Revit. So this is helping us with interoperability. But as usual, most things come out and people are a little bit surprised, taken aback by it, not quite sure what's happening. So this led to quite a few questions. And so I thought I'd just show that today, just as sort of a little intro to show what's going on and where Autodesk are and where they're pushing it. So Revit to Advanced Steel to Revit. So since this sort of started coming in a few years ago, and we've seen a lot of questions, it always comes up on support. You know, what is it? Where is it? How do we do it? Where do we find it? It didn't work. What did we do wrong? All those kind of questions come through to support, even to when we go and do implementations for people. So with the change also with the new steel ribbon coming in Revit, and obviously the progress of the connections, that led us to sort of come, well, let's try and put together some presentation to pass on some information to people and try and alleviate some of that fear of this transition. And it's not a transition, it's more of a collaboration, which is the hub of everything when you think about BIM. It's all about collaboration between different parts of the construction cycle. So, and this was our idea, was to try and bring this across to alleviate some of that and explain it to people. So hopefully from today, we're going to talk over the 2 sessions, we're going to talk about the extension itself, the file type, and the different mechanisms involved behind that, what gets transferred, a little bit of an insight to connections and new custom connections, which Rob sort of already touched on, and he'll probably do a little bit more in his last session, and some of the recent changes and how they've affected in 19. And like I said earlier on, I'm going to hopefully impart a few tips and tricks along the way. So to talk about the extension itself, it's been around for quite a while now, actually. I remember working with it about 10 years ago. One of the first things that always comes up is where do we find it? Until recently, in I think 15 to 18, it was in the App Store. 19, it's in your Autodesk account, so you can actually download it. When you install it, it comes in under the ribbon tab, add-ins. You should find it under there, a little drop-down menu. There is some help as well available. If you press F1 while you're in there, you should get to the help pages, which are quite good, and they are version specific. One of the other questions that does come out, is it different? Yeah, every single version is different, especially in the last 3 or 4 years, and very much so in the last version because of the change in the steel fabrication format and obviously the new steel tools available in Revit. That has impacted on the SMLX file. Some of the previous versions did sort of cross platform, so they would affect the previous version's sort of transfer mechanism. I don't think that's the case with this one. It's a sort of completely independent. And again, you'll see a few hyperlinks at the bottom of the page. So if you've downloaded the PDF, I said at the start, you should be able to click on those, and that'll at least give you a few links as to where to go and look and give you a starter for 10. So how does it work? So there's several different mechanisms behind the transfer file, which is termed the SMLX file, steel markup language file format. Basically what that does is it sort of pulls data from tables inside Advanced Steel, which is a database driven system, and then obviously inside Revit there's family structure, which again has tables and data behind it, and basically it pulls them together for a different series of mechanisms now. Originally, it started off with an expression rule shape driven system, then there was one-to-one mapping, and now there's sort of approved family-based section key transfer. And then there's sort of what I term custom profiles, which can be sort of dynamically mapped as well. And then also there's materials mapping behind all that as well. There's a lot of different options available here, several different mechanisms, and I'll try and explain some of those, how I see them and how I understand them. So I've called this mechanism 1, and this was the original mechanism as I understood it. At the time, it was based upon a couple of database tables which were inside that. They were called the GTC tables because it was originally a Graitec product. It was then purchased by Autodesk, and they sort of have taken that forward and moved on with it. Originally, it was a formula that was actually used in the background. It was quite complex to use. It did work very well. It did require you to read a document and understand a document to do it. And I'll probably elaborate in my next couple of slides on how that works. I mean, that mechanism is still in place and can still be used. And I have seen people literally create their own formulas in these or expressions in the database and transfer their entire section families via this mechanism. So if you could get your head around it, it was quite good. It was quite complex, but it did work very, very well. So a little bit more about that. What it actually did, in the background, it used like a shape reference. So in Advanced Steel, we have a shape code. In Revit, you have a shape code. That shape code has parameters: height, width, length, thickness of this, different ones for that. So, and we have the same thing in Advanced Steel as we do in Revit. So basically, they use those parameters to drive the shape reference to the shape code itself. So this was normally designated by the sort of prefixes at the start of it. Then you had things like H for height, stuff like that, and it was all transferred, which I say it is quite difficult to get it exactly right as to what it should be and what it shouldn't be. It did work, and there was a few documents written about it, but it was more at a programming level, so it's not really easy for an average user to sort of get into that depth and be going into databases and doing that kind of things. They want to do something that's a little bit easier. So what they sort of started doing originally was they basically, the next sort of step on from that was they did sort of what they called one-to-one mapping. This is where you knew what the name was inside Revit, you knew what the name is in Advanced Steel, and you could map the two together quite easily, and it would come up with a mapping dialog, or you could actually manually put the entries into the table if you knew what they were in the database. Again, this does work, and this mechanism is still used predominantly. You can use this to map if you create your own family inside Revit. You can actually map it into Advanced Steel if you know you've created the corresponding family inside Advanced Steel. And the list would be every single section size, because obviously in Steel we have a range of section sizes within a range. So like a 203 by 133 U-beam has a couple of different weights in it, which are a couple of different section sizes, and similarly with tubes, etc., different wall thicknesses, box sections as well. A couple of things that did obviously throw people sometimes was little things like differences between capitalization in letters. It did actually make a difference. I would see people putting it in wrong and they say it didn't work, and it was literally just because it had a lowercase x or an uppercase x in the name. And this did cause a little bit of trouble in sort of this mechanism, but it does work very well. It's still present in the system, and I do use it. So, you know, we have used it to map things across. And if you look in the tables, you'll see over the years the structure of the tables has changed, with the number of entries have gone up and down depending on the mechanisms and the way the process has evolved. It can also be linked to a country version as well by putting some additional entries into the database table. And there's a little tip at the bottom of the page there that actually says that. So I'm sort of calling this mechanism 2. I sort of had to title it something, and this came in a couple of years ago now, and this is where inside Revit there is a section name key that's actually used in the family structure. That section name key actually equates to the section name under Advanced Steel. So this is what we're calling it inside Advanced Steel, and it is mapped basically across the Revit. So this comes with the approved families from Autodesk. So originally, I think in the 18 version, it was a bit difficult to get the approved families right. They sort of came out as a power pack sort of addition, sort of an extra plugin, and it was a bit difficult to find it, to be honest. I found it under a blog page and I had to go and install them. In 19, they've sort of pulled all that together. It's all under your sort of Revit family folder, library. It's all in one place. You really don't have to worry about it. It should all just come in when you install. And what it does is it literally just track this section name key. I do understand it is a hard-coded parameter. It is a mechanism that's used by Autodesk and controlled by them. This is why I'd still say I think you probably still need to do one-to-one mapping if you want to create your own custom family, or take maybe an approved family and adjust it, adding additional data to it as you see. I'm not sure if this might change in the future. Obviously, they might open that mechanism up to the general public, but I'm not aware of that at the moment. And again, I tried to put a little help link at the bottom there to try and explain a little bit more behind what's going on. So here I've sort of done a little video just to try and explain the basic transfer. So I kept a very simple model. I didn't want to do a big complicated model because you can't see what's going on. So I've basically created my own template in Revit here, and I've added in a bunch of the families. So if I was a steelwork detailer, I would just load everything in. I don't want to be looking and loading and unloading families. I would just load all these in. So for this, I've sort of created a few columns and a few beams, and I've the different colors are coming from the fact that I've created some different materials in the system. And I really wanted to just show this as part of the transfer, and obviously to make a difference. So at a basic level, these are just normal steel beams with different materials, different section sizes, and these are using approved families from Autodesk. So I did actually create the materials, I did actually add them in. We'll talk a little bit more about materials later on in today's session. So here we look at the extension. Now, one of the things is when you initially map or open this extension, it will create that little string at the top. It will map all the families to the Revit 2019 folders under the library. It will do that automatically for you. If you don't change any of the settings, which I haven't done in this case, I'm just going to run a very basic export here. So I go off and obviously I've stored it in a particular place. I've given it a suitable name. And obviously you can see I'd obviously run this before when I did it. So I'm just redoing it again and re-recording the video for this mechanism. Now I'm going to swap to my Advanced Steel. So I've obviously got a new file open in Advanced Steel. For those of you not familiar, this is Autodesk Advanced Steel that sits on top of AutoCAD itself. It is actually inbuilt now as well. You can buy it as like all one. It is a true vertical, as I would term it nowadays. So I just select the file through the import ribbon there and the import button, and you can see that it's brought the sections in. Now we've just got primary sections at the moment, and if I click it on one of those, we can see that materials has come across. Okay, I'm going to click on a different one just to show you that I brought the beam size and the material across. It's slightly different materials there. So all this is coming from Revit into Advanced Steel via the mechanism of the approved family. And this is the primary transfer mechanism. Without any joints and that, this is what happens. And if we look at this, we will actually see, I will actually go and access the database in a minute, and you'll see the full list of sections drop down. So this is the way it comes. So this is the structure inside Advanced Steel. So I sections and then the different categories. Obviously depends on which country you're in as to what you get. And then this is the full section range. This can be shortened or lengthened, preferenced if you need to. So that's a direct transfer in from Revit to Advanced Steel. So this is downstreaming it towards fabrication. Now, literally, you might just get that from an engineer. You might not get any connections or anything on it. It depends on what the level of detail the engineer wishes to transpose across, and obviously responsibilities under contracts, etc. But just to sort of come back into the Revit here, you can see I'm sort of navigating the model and looking at the different sections and the properties. And I just want to I'm just going to show you the section key reference. You can see the section key that I mentioned before. This is a sort of indication that this is an approved family with this trigger, and this triggers the transfer from Revit to Advanced Steel and enables the sort of direct mapping, so you don't really have to worry about anything. And from my experience, I found this does work very well, this mechanism. So obviously that was fine if you have a standard family, but what happens if you don't have a standard family? Okay, this can be a bit difficult if you've got something that's a standard shape or a profile that you might use. And when I was actually prepping for this, I was actually working a lot with cold rolled suppliers, and I still am actually. So it was quite good to go and actually sort of look at this, because in Revit you do have a lot of now standard shape codes regarding not just hot form sections but cold form sections, different sections, shapes, and these obviously have parameters associated with them. So a couple of years ago, they brought in the dynamic transfer, and this enables you to send a family or a shape from Revit to Advanced Steel that is not actually a predefined shape reference as a code. It doesn't have a section key in it, probably doesn't even exist inside Advanced Steel, or it might not exist. So by ticking the Export Dynamic button, you can actually send this from Revit to Advanced Steel, providing that it is one of the standard shape codes. And in this case, I picked a C-lipped channel to do this as an experiment, and all I did was tick the box and send it backwards and forwards. And the reason for this is that it enables maybe the engineer might not know what's in Advanced Steel, but at least he could send the section from Advanced Steel from Revit to Advanced Steel, and the fabricator might go, oh yeah, I've got that, I know what that is, or no, I've never seen that one. At least they could get it from A to B and actually have an understanding of what it was, rather than just an image came up with nothing associated, or it got mapped incorrectly, which meant you had to go and change it all. Again, I'll put a little help link at the bottom of the page there. So here I'm just going to sort of show that in sort of action really. So this is going to be using a dynamic transfer button option. Initially I'm going to use a section I found from a cold rolled supplier. I looked on the web, didn't have anything installed. I found this supplier had a particularly good range structured in their system, not just one section with loads of different attributes against it. They actually had each section size, which is what you actually need to transfer it properly from Revit to Advanced Steel, because we have each beam drawn individually inside the steel database inside Advanced Steel. So you need to have the corresponding structure inside Revit really for it to come across correctly with the correct gauge and material sizes. So I'm just drawing a beam here initially. I just picked this supplier because it was one that I found. There was no, I mean, it could have been any supplier, providing they had a family, or you could have created it yourself if you wanted to. Obviously, a little change in material there. You'll see the original material is different, but now if I go back and draw a section, it should draw it with the cold rolled material. And I'll come on to talk a little bit more about that one because that's quite an interesting analogy as well. That's because we use cold rolled as a material inside Advanced Steel. So I've sort of drawn the beams there. I'm just going to flip back and just change this first beam, change its material if I remember correctly. Yeah, I think I do that. Yeah. So also another thing comes into play is positions. So in Advanced Steel, we're quite critical over our system line position. Now this can be changed under the structural framing position from the origin. You can move it. Now we do, in Advanced Steel, it's quite critical for the system line position. It does affect things quite a bit from sort of initial modeling to outputs. We align basically the system line to the top for a top of steel level, or the inside maybe for a cold rolled section, so that it's because if the section changes, it doesn't move its level position. So people don't normally worry too much about this inside Revit, I've found, but it is quite important to sort of think a little bit further ahead now if you're going to be collaborating with a steel fabricator about the positional data. So this is not the analytical position, this is a structural framing position. So with this, initially, I'm just going to send it out without doing a dynamic setting. So I've gone back, I've pressed the Advanced Steel extension button and used the export option here, and I'm going to send it out. So again, I'm going to go and create another file and give it a slightly different name. And this file then we would actually import it to Advanced Steel. So initially I want to show it without doing any dynamic settings, and so you can see what happens. And this is, and what we will show in a minute, is typically what happens. It comes in and it doesn't come in right. I'm going to sort of tell you that before you actually see it. So we've done that again, switch back to Advanced Steel. Just going to create a new file, just so I'm not dragging anything in from before or picking up anything else. I just want to show this coming in the raw sort of first import. So as this comes in, we can see that, so we can see the sections have come in, and they come in, the position line might be right, but the rotation is all wrong. That's because there's a rotation table that controls sections inside Advanced Steel as well. So it was like 3 tables, a combination of 3 tables. And this is typically what happens. It comes in, it doesn't come in right, and it leads to all kinds of problems with the detailer. They're not sure whether the orientation is correct or not. Now, it did pick up the family size, because, or the section size inside Advanced Steel, because I'd actually already previously mapped it, because I knew I was already using it and testing it for something else. But to come back now, come back to Revit, and I'm going to actually change this setting to dynamic. So with this, it's actually going to make a change. Right, and I'm going to re-export the file. So we just come back, we change the setting, press the export button again, we go OK. We don't need to change anything else. Obviously, in a different country, you probably get a different sort of arrangement here. Just slightly different change in the name. So of the file, do the same thing, flip back to my Advanced Steel again. And while I'm in my Advanced Steel, I'm going to create a new file again. I just want to show you it coming back in again. The only reason I have a slightly different template is just the colors, really. I was just trying to make the colors a bit bolder for the presentation today. So pick the file, select the file, and now we bring it in and we can see that the cold rolled sections, the C section, has come in orientated correctly with the system line in the right place. And I'm just going to go under here and show you what's happened. Okay. So the more important thing is, so this is what would happen. It would come in to the fabricator, and it would actually come in orientated correctly. And he might not even have this profile in his system. Okay, that's the other thing to bear in mind. They might not even know this company, or it might be something that's been created specifically for the project in hand. That does happen. People do rolled special sections. And what is happening now is this has been created so on the fly to speak. This section only exists inside this model that I've created it in. So this is where it's a custom profile that's come from Revit into Advanced Steel. It resides inside the Advanced Steel model. And it's because it is based upon a standard shape code, but it is not a known family. Now, I actually do know that this is a known section size inside Advanced Steel. We do have Albion sections inside the database. So as a fabricator, I might go, oh, I actually know what that is. Oh, I could actually change that and actually bring it into a core profile within Advanced Steel. So that's probably what I'm going to go and do here. I think I do go off and I draw a little section just to show that. I go off and find the section under the Advanced Steel system. So again, objects, little drop down list here, it's cold rolled down the bottom of it. So I can manually draw a cold rolled section inside here. That's it, I pick the button, draw it out. And with this, you can now see that it's actually gone back into the core of Advanced Steel. So I'm looking inside the database. This is where we access all the profiles inside Advanced Steel. And we do have that same section size listed under here. I sort of scroll down in the list here and we see it down the bottom of the list. Now, what I can do is obviously to change this. I mean, you can do this with match properties under Advanced Steel, and there are options to select the steel properties of that as well as the AutoCAD properties. So in this case, I'm actually unchecking a couple because I don't want to alter all the positional data. I just want it to change the section size over. So I'm just going to do that. I mean, there is a lot of little checkboxes available if you don't want to transfer bits or you do want to transfer some bits, but I only want to change the positional data in this case. So with that, and then it'll come up with the AutoCAD part of it as well. So then I just click them individually. Now you could window them, you could have them in a selection set. You don't have to do it like that. I just did that just to show them individually. And now when I go back and look at the section, I found that I've actually changed it. So it's actually into a core profile that's actually within Advanced Steel. But at least I knew what it was before I started, where I've had the problem before where I don't get anything at all, and I'm not even sure if there was something there in the first place, or I've mapped it to something incorrectly that I've then had to go off and alter again. So sort of moving on from that, the next bit is to do with sort of materials. So materials in Advanced Steel, okay? We have materials inside Advanced Steel, we have materials inside Revit, and I found through testing them, we need to try and align these materials or else you end up with a dialog popping up telling you that you need to map the material each time. So within this slide, you can see the differences between the two parts of the system. And basically what we need to do is in my opinion, if you're working within an organization or if you're sending it to someone, you've created a bunch of materials, it's just a good practice to let them know that you've done that. Okay, if you let them know that you've created a bunch of materials, then you can get it to sort of come across between the two platforms because it gives the option for the detailer to create the materials or for maybe the technician in Revit to create the corresponding materials. They might have to create a mapping, but at least it will stop them going around a loop, which I found it sort of keeps changing it or creating materials on the fly, which then don't match with the materials that are actually in your database. So again, same sort of model here, and you can see in this model the sections for the cold rolled are not actually in a cold rolled material. In Advanced Steel, we use a section called cold rolled, a material that is linked that, and we do that for very specific reasons. It sort of links to how we do drawings, how we isolate it in the model, etc. We can all kinds of things we can use to do that. So I just drew this particular section as it was in the Revit model. It's in a core material, basic material, the S275. And what I did do is try to create a material inside Revit. And when I initially did this, it wouldn't work when I sent it backwards and forwards. And I sat there looking at it thinking, I'm sure this works properly because we have cold rolled inside Advanced Steel. So I'm looking here inside Advanced Steel. And under that, I can see the material in place here, cold rolled. So I thought, well, it must be. So I created the corresponding material back inside Revit. So when I sort of went back to Revit, I think, okay, yes, I've created the material. And I created it first with cold space rolled, and it didn't work. When it brought it in, it created a new material on the fly. And I thought, well, why did it do that? So I thought I must have done something wrong. So I went back, checked what I'd done again, And I thought, no, I'm sure it's something I'm missing here. So, be honest, me being me, I went off and had a look inside the database. I looked at the materials mapping table. So this is the mapping table that's hidden inside the GTC database. I mean, it has quite a few entries in it, well, hundreds of them to be exact. Some against different applications as well. So I sort of took a while to scroll through this and try and find the one that I wanted. I saw the ones that I created at the bottom because I knew the key value I'd created them under, but I thought there must be an entry in here somewhere that's sort of throwing me off what I'm doing. And it does say, literally, this is me having a look, trying to find it. So I was sort of scrolling through here, thinking, oh, it must be in here somewhere. And eventually, I did find it. So I did sort of going up and down here. I had a quick look, and I thought it must be in here, must be in here. So because it's just not coming across right. So I had a look, and eventually I sort of picked on an entry, and I found it. And I noticed something that I hadn't noticed before, is that there was a slight difference in the way of the wording of the file between the key value. And you can actually see it there at line 451, which is in the middle of the screen there. It's cold rolled, but no space in it. So I went back into my Revit platform, and then obviously my material that I created for Revit, I had to create it with that same key value, which was, there was no space in the name, so between cold and rolled. So from that, I determined that material key obviously had a slightly different name than the actual visual representation or the display name that you see in Advanced Steel. So with the material being set as cold, no space rolled, I went back and just checked again back inside Advanced Steel, and I can see this in here, and it says cold space rolled. I thought, yep, that is the display name, but the key name behind it is without that. So now I'm just going to come back into here. I'm going to transfer this. I'm going to change this material and set it to cold rolled. And I'm looking here in the materials table. So this is the materials table inside Advanced Steel. And you can see cold rolled there. And you can see the bit I'm on about. It's the first column. It says cold rolled, no space. But the run name or the display name has got a space in it. And I fell into this trap. This is why I said it's very important to make sure that whatever materials you create inside Revit, you create corresponding materials inside Advanced Steel, or at least know what the material should be between the two different softwares. Especially if you're working in-house in a company, surely it must be quite easy to do this, to coordinate it. It's a little bit difficult as an external company, but it does make a difference, and it cuts out a lot of remapping of entries and stuff and things changing when you're going backwards and forwards. So here I'm just going to change these to cold rolled. So let's change those entries to cold rolled, and then I'm going to re-export the file. So come back to the extension again, settings, just check, leave everything set in there, make sure it's okay. Yep, and then I'm going to go back and press the export button, and then I will take that file and put it back into Advanced Steel. Just done that, just give it a slightly different name again, so we make sure it's got the right, so we know what it is. I would always recommend that you do keep track of your files. I mean, obviously you can use the same file name each time if you're just doing this backwards and forwards and use one file, but if you want to just keep track of different files and where you are, you could create a different series of SMLX files. Again, I'll just create a new template in here, and then I bring the file back in. So use the import button again, go and pick the file with the material. We'll bring it back in. Obviously the section's right rotation, etc., because of the dynamic settings that I set. So we can see that this is just a basic one, and then I'm going to come and look at the cold rolled section now. And we can see, if you look under the material, first it's pulled the beam in. The beam is dynamic. It's because we set it that. Okay, that's what it would transfer it in as. But the steel material says cold rolled under there. It says steel cold rolled, so that is the Advanced Steel material, so it mapped straight away. I didn't have to go in and do any funny mapping. And that is the same for all the sections here as well. They will all be the same, and obviously just to come back and just show this obviously back inside Revit as well. So that probably seems a bit of a breakneck speed. Hopefully there'll be a recording of this after today. that really does bring us to the end of our sort of presentation today. So that was, we do have another one next week, which is part 2. And then there will be a further one after that, obviously for doing Fabit, where we sort of take it into the fab details. So hopefully that gave you a very brief and quick insight. Please do come and watch part 2 next week. It's sort of, we'll go a little bit more into the steel fabrication format, the transfer of connections, etc., and what's going on in the background there as well. Thank you very much for attending today. Thank you for your time. If you need to reach out to me, my email is at the bottom there, and it's also in the PDF file that I attached under the handout. Thank you.